Dependent probability. This means one thing depends on the other. So the definition, remember you can pause this at any point. Okay. A dependent event. The occurrence of one event does affect the probability of the second event. So if you have a bag of M&Ms, you pull an M&M out, you want to pull a green one, and you pull one out and you got a green one. Well, you don't put it back in there. Okay, so that means your next choice is affected by your first choice. Okay, because you have one less green and you have one less total M&M in that bag. So to find the probability of two or more events, you do the exact same thing. It's the probability of A and B. Then you just multiply the probability of A times the probability of B. The only thing different is the probability of B will be different than the probability of A. Okay, so if you can draw this stuff down here, it's the same little drawing as the last one. There's a can. There's 5 red. I don't care. You can call them whatever you want. 5 red markers, 2 green markers, 2 black markers, and 1 purple marker. So we're going to pick a oh, never mind. It says marble right there. Sorry. So we're going to pick a marble. We're going to keep that marble, and we're going to pick another marble. So this is a little different. You have to assume that you pick what you wanted. Okay. So pause this right now if you need to, and we'll get started. All right. So let's find the probability of picking a green and a red. Okay, so what is the probability of picking a green? How many marbles are in there? 5, 6, 7, 8, 9, 10. There's 10 total marbles. So the probability of a green, there's 10 marbles. How many are green? 2 are green. So that is 2 out of 10. The probability of picking a red. So remember, we're going to pick that marble. We are not going to put it back in the jar. Okay, so how many marbles are in there now? There's now 9 marbles. Okay, how many of those marbles are red? 5 of them. 5 of them are red. Okay, so what do? All we have to do is multiply these two events, and that will tell us the probability of both of them happening at the same time. So let's look at cross-simplifying again. So 2 and 9 do not have anything in common. 2 does not fit into 9. Okay. 5 and 10, they're both divisible by 5. So if they're both, if they're both divisible by 5, 5 divided by 5 is 1, and 10 divided by 5 is 2. So now we can just multiply much easier. 2 times 1, which is 2, and 2 times 9, which is 18. Now that can still be simplified, but it's a lot easier. You notice that they have 2 in common. So just divide them both by 2, and you end up with a 1 in 9 chance. Okay? So a 1 in 9 chance. All right, let's do the probability of getting a black, then a purple, then a black. Remember, we're not going to put these marbles back in. Okay? So how many marbles in total are in there right now? For our very first drawing, there are 10. How many of them are black? 2 of them are black. Alright, so we pick a marble out. We don't put it back. There's not 10 marbles anymore. There are now 9 marbles. Okay? So the purple, how many of them are purple? 1 of them is purple. We don't put that back. It went from 10 to 9. We drew another one. Now there are 8. 8 marbles. And how many of them are black? This is where we mess up. So let's think back to the first one. We chose a black. There were 2 black ones in there. How many are there now? There's only 1. Now we're just going to multiply straight across. Nice easy numbers. 2 times 1 is 2. 2 times 1 is 2. And then let's do 9 times 8, which is what, 72? And then 72 times 10, 720. 720. So 720 is an even number. 2 is obviously an even number. They're both divisible by 2. So we will divide them both by 2. Half of 720 is 360. So there's a 1 in 360 chance of pulling a black one, then a purple one, then a black one. Not very good odds. All right, let's do another one. Yeah, we'll just do one more. Let's do the probability of drawing a red, then a red, then a red. So remember, there's 10 marbles in there. Change colors, sorry. The first drawing, there are 10 marbles. How many of them are red? 5. Okay, so we're going to assume that we chose a red, and we're not going to put that marble back. So there was 10. We take one out. We don't put it back in. There are now 9. How many of them are red? There's only 4 of them in there that are red now. It's getting smaller and smaller. We're going to draw again. There were 10. We didn't put it back. There was now 9. We draw again. There's now 8. Same thing with the amount of reds that are in there. There were 5. We took one out. We didn't put it back. There's now 4. Took one out. We didn't put it back. There's now 3. Now we just multiply. This is where cross-simplifying will help you a ton. Okay? Let's look and see what we can simplify. The 4 and the 10. Actually, let's not even do that. Let's just think about 5 out of 10. 5/10. What's that the same thing as? Isn't that the same thing as a half? No. Same thing as a half. Now we can look at the 4/9 and the 3/8. 4 out of 8. Both divisible by 4. 3 and the 9. Both divisible by 3. Oh my gosh, that's so much easier. Look, now our numerators are just 1. So 1 times 1 times 1, 2 times 3 is 6. 6 times 2 is 12. Make sure that you get all that written, and don't let the cross-simplifying distract you from the actual dependent probability practice. I will help you on your assignment next.